All right, let's get right to it. Your first-term science exam is coming up fast, and we are about to cram everything you need from the first 4 chapters into the next few minutes. Think of this as your high-speed, high-impact review to make sure those key concepts are locked in. I know, it can feel like a lot. You've got biology, chemistry, physics, and ecology all thrown into one test. But seriously, don't worry. This right here, this is your secret weapon. We've boiled it all down to the most critical, must-know points for your exam. So, you ready? Let's dive in. Okay, so here's our game plan. We're going to move fast through these 4 core topics. We'll start with the biology of respiration and blood. Then we'll jump into the chemistry of materials and solutions. After that, we'll get into the physics of forces and motion. And we'll wrap it all up with the big picture, ecosystems and interactions. Let's do this. First up, biology. This is all about the absolutely essential process of how your body gets oxygen and, more importantly, how it uses it. It's basically the fuel that runs you. So on the left, you've got the whole setup. The main airways and the lungs, it's all basically one big pathway to get air inside. But where the real magic happens is deep inside at the end of that path. On the right, that's what we're looking at, the alveoli. You have millions of these tiny, super thin air sacs, and this is the spot where the oxygen you breathe actually meets your bloodstream. This is the place where the exchange happens. So, how does oxygen actually cross from your lungs into your blood? One word, diffusion. This is a huge concept in science. See, when you breathe in, your lungs are packed with oxygen. That's a high concentration. Your blood, which just got back from delivering oxygen to your body, has a low concentration. So the oxygen particles just naturally move from the high concentration area, the lungs, to the low concentration area, the blood. It's a simple process, but it's literally what keeps us alive. Okay, pay attention, because this is a classic exam question. What's the difference between breathing and respiration? They are not the same thing. Breathing is just the physical part, the muscle movements that pull air in and push it out. Respiration, that's the chemical reaction that happens inside every single one of your cells to make energy. You absolutely have to know this word equation. Glucose plus oxygen produces carbon dioxide and water. Memorize it. It's pretty much guaranteed points on a test. And what carries that precious oxygen around? These guys, red blood cells. And they are just brilliant examples of design. That weird biconcave donut shape, it gives them a massive surface area to soak up oxygen fast. They're also stuffed with hemoglobin, which is like a magnet for oxygen. And get this, they actually get rid of their nucleus just to make more room for even more hemoglobin. Their whole existence is built for one job, transporting oxygen. All right, let's switch gears to chemistry. We've talked about gases. Now let's look at liquids and what happens when we start mixing stuff together. First, let's get our vocabulary straight, because you're gonna need it. The stuff that gets dissolved, in this case sugar, is called the solute. The liquid it dissolves in, the water, is the solvent. And what you get when it's all mixed together is the solution. So solute plus solvent gives you a solution. Simple enough, right? But what's actually happening on a tiny particle level? Well, the particle theory explains it perfectly. The water particles are always moving around, and they start bumping into the sugar crystal. They knock off individual sugar particles, surround them, and carry them away until they're spread out completely evenly. So the sugar didn't just disappear. Its particles are just hiding out between all the water particles. Okay, knowing how to read one of these solubility graphs is a super important skill for your exam. It looks complicated, but it's not. You just pick a substance on the graph, one of the lines, and you follow it. See how for most of these salts, as you move to the right, which means the temperature is going up, the line also goes up? That just means you can dissolve more of the substance when the water is hotter. So if we can mix things together, how do we pull them apart again? Paper chromatography is a really clever way to separate mixtures like ink. As the solvent, the water, creeps up the paper, it starts to drag the different colored ink particles with it. But here's the trick. Some colors are more soluble or stick to the paper more than others, so they all travel at different speeds. It's basically a race up the paper, and the result reveals all the different colors that were hiding in that single spot of ink. All right, big gear shift now. We're jumping into physics. We've been looking at the tiny, microscopic world, but now let's zoom out and look at the big world of forces and how things move. This is pretty much the most fundamental rule of motion. Check out the rock on the left. You've got gravity pulling it down and the ground pushing right back up. The forces are equal, and they're in opposite directions. We call that balanced. The result? Nothing.
The rock just sits there. But now look at the right. A big force starts pushing it. Suddenly, the forces are unbalanced. And what happens? The rock starts to move. It's that simple. Unbalanced forces cause a change in motion. And when things do start moving, we need a way to calculate how fast. This little triangle here is going to be your absolute best friend for any problem with speed, distance, or time. The way it works is you just cover up the thing you want to find. Need to find speed? Cover it up, and you see you've got distance over time. Need to find distance? Cover it up, and it's speed times time. You got to know how to use this. This table really just summarizes everything we need to know. That first row, that's our rock just sitting there. Equal and opposite forces, totally balanced, no change in movement. And the third row, that's our rock getting pushed. The forces aren't equal anymore, so they're unbalanced and its speed changes. If you understand these 4 scenarios, you can figure out any forces problem they throw at you. And for our last chapter, let's zoom all the way out. Let's look at ecology and see how all these different branches of science, biology, chemistry, physics, all come together out in the real world. A food web can look really complicated, but it's telling a pretty simple story about one thing: energy. The key is to follow the arrows. The arrows always point in the direction the energy is flowing. So, the energy flows from the cactus, which is a producer because it makes its own food, to the kangaroo rat that eats it. Then, the energy flows from the rat to the rattlesnake that eats the rat. It's all just about who eats who. Now, that food web is just one part of a much bigger thing called an ecosystem. The most important part of this definition to remember is that an ecosystem isn't just about the living things. It's about how the living parts, the biotic parts, interact with the non-living or abiotic parts, like the sunlight, the water, the air, the soil. It's the whole entire system working together. And that leads us to another key difference you have to know: ecosystem versus habitat. A habitat is just an organism's specific home inside an ecosystem. So the whole desert is the ecosystem, but a single cactus that a bird nests in, that cactus is the bird's habitat. Think of it like this: the habitat is the address, but the ecosystem is the whole city. Okay, let's do one last super fast check. Do you know the word equation for respiration? Can you read a solubility graph? Can you use that speed, distance, time triangle? And can you explain the difference between an ecosystem and a habitat? If you can nail those 4 things, you are in really, really good shape. And as you finish studying, think about this for a second. We started with biology, talking about why you need oxygen, and it all came down to diffusion, which is a fundamental idea from physics and chemistry. Science isn't really a bunch of separate subjects. It's all one huge interconnected story. Your job is to connect the dots. Now go ace that exam.